Let me start lecture now. Okay. Can everyone hear me or see my screen? Just like in the chat or something, just to make sure. Okay, nice. Thank you. Thank you. Thank you, Ariane. So let me present. Start. So hello, this is week 4. This one, oh, you can't hear. Giovanni. Okay. Let me see. Wait, can you all hear? Wait, someone else confirm. Or I might switch audio. Okay, you can hear. Okay. Okay, nice. I'll just start. It's gonna be recorded anyway. Let me see. Okay. Yeah, you can just disconnect it and come back. Don't worry. I'm gonna have to start lecture right now. So this is week 4. It's on collaborative filtering. Last week was more on content based. So just focusing on the single item. This week is more on collaborative, which means that you try to collaborate between this user and another user and try to find like similarity patterns in order to predict what to recommend for like a new unknown user. So let's go into more detail. So a little bit of content. I make this week pretty short, and I try to get like all the slides in done. And it's like there's a little bit of math and theory in there, but it's midterm season and I'm trying to get this thing right. So first I'm going through the examples of collaborative filtering, like very general industry example. Then I go to definition and how collaborative filtering would be applied into like the classification or regression problem that we talk about in week 2. So this week I'm just going to talk about one of the 2 most used methods for collaborative filtering, which is naive-based classifier and KNN, so K nearest neighbor. And last, I'm going to talk about like out of all these models, like in the end, how do you measure success? Like, what's the detail on like getting the success of this model done? So without further ado, like go into collaborative filtering. So what are some examples of collaborative filtering? So this one, I just took like some example from Amazon. So Amazon, like if you already use it, it's usually after you buy a product, it recommends product that similar user buy, like would buy. So what does that mean? For example, if you bought like, I don't know, a book about like beginner programmer or something, and then it looks at other users who are similar to you, like who also bought this book, and oh, what other books do they bought? So there's like point and programmer or something like frequently bought together by with other users, or like they would word it in a different way, like customer who bought this item, like your book, also bought like items like this, like these 3 books. So in industry, they use that a lot. For example, in Amazon or in Netflix, they word the problems a little bit differently. Instead of like books or like items you bought on Amazon, they would word it, for example, like there are this movie you've watched and you rate it well, you love this movie. Here are some similar movies that other users like similar to you would also watch. So that recommends like you're this type of person who you rate this movie well. So what else would you like watch, or what else would you buy? And so the big idea is that, for example, like just same idea, like, oh, if I like A, B, and P, like apple, banana, and pear. Another customer, maybe Andre, like the one who's lecturing last week, he likes apple and banana. And so we kind of have like some similarity going on here. Like we both like apple and banana. And then the question is like, would he like pear or not? And so based on like the general assumption of collaborative filtering, it's more likely, he's more likely to like pear too, given that, oh, all the list of items that we both like in the past, like comparing to each other, there's a lot of similarity going on. So that's the big idea. And like mathematically, like you would look at, you would consider a new user U, and what your test is to find n other similar user to you, rating wise. So for example, I rated apple and banana well, like I liked it rather than disliked it. So I rate it well. And so find n other user that are similar to this unknown user U. And after you find all the other n similar user, predict, like compare, like get all those other n user, predict U's rating based on those other n user. So just definition of collaborative filtering, like boil down, try to not boil too much, but it's try to use similarity between like an unknown user, like in a test set, not a training set, and try to find similar user to recommend, find all the similar user and use their like ratings, like all combined, like to figure out like what to recommend you. So there's two common types of collaborative filterings going on. And the common two are user-based and item-based. And today I'm just going in more on item-based, because if you understand like the just the gist of one of them, it's easy to like easy to put it like the problem in the other one. So mostly today is on item-based. So mathematically, what we're like trying to represent the problem of finding like what to recommend to user X. So you have like this new user X, and this is your end user, you like, well, not end, just X, like a new user. So suppose that you, X has some sort of like preference, like, and like the n other user, you're trying to find similarity to between n and X and n other user. And your end goal is to recommend or to not recommend this product. And so the whole idea of collaborative filtering is that in general, you have a user set U from like all the users, like from 1 to like a certain number of U, and the item set I, and you're also given a training set T. So training set T is complete. It has all of the ratings available for all the users. So training set T contains like all of the ratings. The rating, let's call it RUI, like rating R. UI means like a little bit of notation. Rating R, like a rating scale value of some user item pair, like UI. So RUI. For example, RUI is like user U rated item I with this R value. So for example, like a restaurant or like an Amazon item, it has usually like star scale from 1 to 5. Usually you can like hover over the star and rate it. So 1, 2, 3, 4, 5, or some might go 1, 1.5, like it'll just be double the amount of ratings, but like a discrete set of ratings. So that's an example of like what our rating scale would look like. And given all that user set, item set, and this complete training data set T of ratings, so your goal is to predict unknown pair of UI in a test set. So like, for example, like in the test set, maybe like delete some of the ratings. Like you have the true test set value, and here are some deleted. So you're trying just those deleted are more question mark, and you can represent like the rating matrix, all the ratings of users and items as a matrix, with the row being like the number of user and the column being the number of items. And your goal is to like, okay, now you're in the real world and you have like kind of blank spot, like a lot of question mark going on in the matrix. So the matrix is kind of sparse at the beginning because you have like a lot of missing data. Okay, try to figure out what those missing data are. Because just in real life, some users have already rated, for example, 1 and 4 for like certain items, like item like 3 and item M. But they've never like known the first 2 items, like some other items. So based on similarity, can you find some similar user in this whole matrix to like figure out like, oh, what are these 2 question marks here for user 1 for the first row? So that's an example of like finding the question mark. So we're gonna get into like the big picture. I try to synthesize like what the collaborative filtering will be. There's some info that we're gonna skip today on data prep, but usually you come in and you have all this given. Oh, wait a second. Where are the slides? Wait. Usually you come in and you have all these all these information, like user set use. So you're given all these data, like all the use available. So here are these number of user, here are these number of items and the rating between them. And after you're giving them, you do some data preparation. So removing like there's some like common things, like I can go put them more into details in the homework, or I'll decide that soon to like release. But there are some data preparation steps in collaborative filtering, like bias, term, and shrinkage, just to make like the data set. These are the 2 common steps that trying to make the data a little bit more balanced. So for example, some user like rate more than others, like, or some user rate more because they're biased, and some don't rate at all because they're just enjoying life and they just buy stuff and they don't rate. And so these 2 steps are like just some like example of how to like leveling all the users. So we're not going to focus too much on that today, but we're focusing more on the classifier models, the naive Bayes classifier and the KNN specifically. So the KNN one is the most used classifier, but I'm going to go touch over the Bayes 2 first. To review some of the stuff that we went through on week 2. And then in the end, I'm going to talk about, okay, given all this, like you're given all the data set and you develop these whole model, in the end, how do you measure if your model is actually working? Is it successful or not, like error or not? So some of the, I should like include more. There's a few more root mean square and another method. So like these are some like error equation that you can like put up on your output versus ground truth to find what is difference between them, what's the error between them. And so first I'll go over like some model on classification regression. Actually, I realized the 2 model I include today, KNN and Bayes, are more of classification, but it works the same ways at regression. But if I go into detail in regression, it will be a little bit more hairy in the math, like ridge regression. So I'm just going to stick to the easy 2 example because it's already a lot of math. So classification. I should have just removed the regression, but there's some regression model out there for collaborative filtering. So okay, classification. What are they? So For collaborative filtering, you can treat like your whole problem of predicting all those missing like holes, like missing part of the matrix, as like a classifying problem. So you can choose, like in real life, you can choose like any of the classification regression of your choice, and you try to do like when you choose the classification, you try to do one for each item I. So so first you look at item I, just the item I across all user, and then represent each user U, let's just say U, wait, not UI, as a rating vector for like all the items. So for example, I have like this rating vector U, RU, and so user U already rated like the first item, for example, first movie as 3, like mediocre, like okay. And you don't know what the second and third, and this user U like rated like just a few, like 5 of them. And the other 4, like he or she hasn't rated yet. And so this is what like you're trying to represent, like a user U rating vector as this. And you're trying to predict like the missing part. And so treat all of the values R, you try to treat all of the values R in this vector as some discrete set. Like I said before, it's either 1, 2, 3, 4, 5, or maybe it's just like 0 or 1, like or dislike, or maybe 1, 1.5, 2, 2.5, like there's some discrete set going on. And you're trying to predict these in discrete sets. So this is more classification now rather than regression, which is more of continuous set, because you represent it discretely. So yeah, your task is to find out the entirety of RU, the rating vector for any like unfinished user U, rating U. And the approach is that use that classification in regression and say, today I'm going to use like KNN and naive Bayes classifier because it's a little bit easier to like start with right now, as we have. Let's see. So you try to train these classifiers separately for each item. So let's go into naive Bayes classifier. So just a refresher what naive Bayes was on week 2. So naive Bayes was on like just focusing on these 2 equations down here. I copy it from like my week 2 slide. So remember the between the discriminative and generative model, where like if you refresh the generative model where you're finding like boundary, I can like go out a little bit. Wait a second. Need to. Oops. I can go like refresher like a little bit on week 2. Just excuse me, wait a minute. Okay. So here, like if you remember the Bayes classifier between discriminative classifier and generative classifier, I think you guys can all see this on the week 2 slide I'm presenting just briefly. But it's just recap, like I'll go back to week 4 real quick. The discriminative and generative, you're trying to find the distribution of the data rather like some more extreme decision boundary. But you're trying to find the distribution of data using like Bayes theorem or more statistic on like finding the prior and the likelihood probability to get this whole like mapping circle of like the of like the data space, like the data distribution within like that space, given space. And so just refresher on this, probability, like just use some prior and likelihood. And for this, like same thing that it's apply on collaborative filtering. We want to use naive-Bayes classifier on this. So how are we going to use it like that? So we know that first we are going to give some assumption to our problem. So let's assume, just going to reiterate one of the assumptions and the other one is new. So the first assumption again is that your data is going to be classified discretely. So it's either within, for example, this set of discrete value from 1 to 5, or from 1 to 10, like out of a scale of 1 to 10, some discrete scale. And then second assumption you're going to make before doing naive-Bayes classifier is that you're going to we assume that if like all of the ratings of a user is independent to each other. And for example, like ratings of a user from R1 to RM, like these are all the ratings of, for example, movie, from movie 1 to movie M. All of these ratings are independent, just like think of it independent for now. It will be much hairier if it's dependent. But for example, if you have this white circle, it's like if you have a rating for a certain movie, this white means you already know the rating. And like green means you might know, like either yes or no. More likely you don't know the rating between like of that movie. So just in general, all the movies are independent. That's the main idea. Now, after you have those two assumptions, you're tasked to find like the rating R UI, R sub UI, meaning the rating of like that a certain user given to an item I. So how are you doing that with Bayes theorem? In order to do Bayes theorem, first, in the end, you're trying to find the posterior likelihood of that rating. Like, is that rating probably going to be like in 1, 2, 3, 4, 5? So the posterior probability. And in order for you to find the posterior probability, you need to like know prior, likelihood, and evidence. So usually you already know evidence, but you need to find the prior and the likelihood. So that's like, yeah, with a lot of other like ML problems, like the thing you don't know is prior and likelihood. So you're tasked to first, before you calculate posterior, like the probability that rating UI is like going to be, I don't know, 1 or 4. In order to determine that it's either like 1 or not, then you need to find prior and likelihood. So some notation, prior is like so like some notation. Okay, let me see. I put it up on here. The white circle RI, I will just call like the white circle RI, like I already know it. Oh, sorry about earlier. So the green circle are ones that I think you don't know yet. So this one is X and this one is Y. So given like the probability of rating towards item I as R, like you're trying to determine all the other greens ratings. And so wait, let me go to here. In order to find, the first one is prior, and the second one is the likelihood. So some mathematical, like how you would find the prior and the likelihood. So you first look at all of the user who already rated a certain item I, and you train it on a base classifier on those users. So first look at all the user on item I, probability of like the user, like the rating of item I is like a certain value, like 1 or 2 or 3 or 4. V is like notation for like value. Choose it like, it could be like 1 to 5 either. So you're trying to loop it through you're trying to loop it through like all the values in the discrete output set. And so you count. So the main idea for the math of how to find like the prior and the likelihood is that for both of them, you're trying to count the number of like ratings that ends up with that, like ratings that ends up with like let me try to get this right. Count the number of user instances that rated that certain value. So for example, summing up, like count 1, like +1 for each summation, for example, this notation. Did the user like you rated that item I as 1, as V or not? So V is just a quick notation, like just some what do you call that in statistics? Like just some random variable in the set. For example, if my probability of Ri equals 1, so look at all of the user who rated from item I. If they actually rated 1, then count it in the summation. If they did not rate it as 1, then don't count it in the summation. So you're just finding the sum of like all the user who like rated for that certain scale value. Okay, yeah. And so after you are trying to loop over of all of the certain scale values, finding all the certain the prior and the likelihood of all those certain scale values, then we find the posterior, which is just like just trying to like this whole equation down here is just trying to find is similar to this, just a like derivation of like the basic posterior equals prior times likelihood over like the evidence statistic equation of state. So that's just finding like applying like likelihood and prior at the on the top and then divided by like all the px in the bottom. And so but your homework is not going to go through that because that's going to be a lot. So I'm also including the more commonly known one, which is the KNN. So your homework is more on, I think, like on KNN, this one, and I'm trying to finish up like quick touches on the end to release it soon for today or tomorrow, so don't worry. So let's go into KNN. So the previous one is base classifier, where you're trying to like fit this collaborative filtering into the base classifier naively, like assuming that it could go into base with some like assumption everything is independent and such. Now we are switching here to a different like classifier, which is the K nearest neighbor. So for K nearest neighbor, we're just, before we go into K nearest neighbor, is the same assumption that we're using for base classifier. So also represent, oh, there should be an image here. I think it got cut out. So represent each user U with a vector, like a rating vector R. So if I go quickly out, oops. So the rating vector R, you also like represent the same thing here. So represent user, each user U has a rating vector. And for example, it could be like complete or it can be sparse, incomplete. And so that's your that's your like assumption. You should still represent that user with the rating vector R. And now after you have those basic assumptions down, now put it into the KNN problem. So refresher, what on KNN is? KNN is just a shorthand name for K nearest neighbor. K is just like a like 1 nearest neighbor, 2 nearest neighbor, 3 refresher. Maybe you guys got it in 61B. But you're trying to measure like K nearest like neighbor, like distant wise neighbor from like the known. And like, for example, like I have an unknown like point, and you're trying to find, for example, like K equals 3 nearest neighbors. So I will determine my value from other 3 nearest neighbors around me. And in order to determine the other 3 or like some other K value of neighbors nearest to you, you need to have some distant like measurement. Usually they use like Euclidean coordinate distance for classical like KNN problem. But for collaborative filtering, the difference is that we're using similarity distance, which I'll go into like very quickly. Similarity distance is trying to find like how similar are 2 rating vectors. So like our assumption, we are representing ratings for each, like rating for each user U, like as a vector. And so like try to find like the similarity between user U1 and U2, like is the same as wording the problem with trying to find the similarity between 2 vectors. And so how do you find similarity between 2 vectors? So there are a few ways, but the two most efficient one is cosine similarity and Pearson correlation coefficient. Jacquard, I'm not gonna use it, but it's used in some of them, surprisingly. But the most commonly used one is cosine similarity. And so I recommend using one. So I think Andrea touched up on cosine similarity between like in the previous week 3 lecture. And you can either, there's already like a mathematical equation, like just abstractly, these are like calculating between vector X and vector Y, like how different are they? And also like same with Pearson. Let me see. But the only problem that we're faced with is that, okay, now like finding the, like now we are looking at, for example, an unknown, like an incomplete user, incomplete rating vector of user like UX or like a new U. And now we're trying to find like KNN for all the user around X. So how do, like X is incomplete, but all of its neighbor is complete. So what I mean by is, let me get to that vector. So for example, this is your test set. Your test set is like, there's a lot of missing holes going on. But your training set, for example, all of your rating vector in the training set are complete. Like there's no question mark in there. But your new data point, let's say a new data point introduced, and you're trying to find like all the question marks. It has, and the other ones are complete. So how do you then be like an incomplete and complete rating vector? So in order to do that, you're gonna add a little bit more assumption. is we're going to simplify the problem even more to look at like the distance between a incomplete and a complete vector. Oh wait, why is this thing? You only need to look at the values that are already filled in, like that both have. So if one of the two vectors doesn't have like a value, because if it's missing, if it has a question mark, don't look at that value. Only look at values that are already there. And so that's just our quick solution for collaborative filtering. And so how do you, after you use like Bayes classifier or KNN, how do you like measure the success of your model? And so there are like two mostly used ways. So it's either root mean square error, where Q, like this Q is like the number of like data point in the test set, like absolute, like the set size Q. Absolute value of Q is like how big is the test set. Root mean square error is like, I think you have already seen RMS square error equation. It's just squaring between the difference between the ground truth value and the predicted value of square, and then all like average across like the number of test sets. Same thing, almost the same thing with mean absolute. It looks sort of like the L1 and L2 loss. If you look at like, oh, this one is square, this one is absolute. And so this is going in the same direction as the L1 and L2 on like week 2 like content. But for both of them, since they're taking the mean, and it's just some like little modification. And I think that is it for this week. Yes, it's pretty short, but like math is like a lot. So if anyone has some questions, I can like stay. But for some like just to announce a little bit for like the homework, it's not. I think I'm going to release it. I need to fix like some problem on the homework, like some little details before releasing it out on Piazza. So the homework is going to be probably released tomorrow. I'll work very hard to make it released tomorrow. It's going to be on the same Piazza post. So I posted on the Piazza logistic. So what the quiz? So the quiz is going to be stay posted. Like quiz is going to release like end of today, like real quick after the lecture. And try to finish the quiz by tonight or tomorrow. There will be like a deadline posted up, and homework's going to be posted tomorrow. Yes. And I will try to make the homework based on more of like KNN, so that you're used to more of like the theory of collaborative filtering, instead of like, because using a Bayes classifier it might go through a little bit more math and it doesn't focus much on like the big picture. And so that's it for today. Yes. You have any question? Wait, chat. Is there a quiz today? Let's see. Homework 3 or homework 4? Let me see. Let me see. I think right now we're deciding on if we're doing weekend, then the homework is on weekend -1, because we had like a little hiccup, and also it's better for students to like review the week before. It's the week due tonight. I will post it up soon. I will like probably give some leeway on like we can do tomorrow by tomorrow night. So don't worry about that. Is there a quiz for today, for this lecture today? Yes. Okay. Okay, that's it. Okay, that's it for today. Yes. Any questions? Yeah, short lecture.